Welcome to the deep dive. Our mission today, well, it's pretty laser focused. We're taking a bunch of dense infrastructure source materials, think professional automation specialization stuff, and boiling them down to the absolute essentials. What you really need to know about building, securing, and maintaining the core orchestrator platform.
Yeah, think of it like getting a technical master key. We're not really digging into, how to craft the perfect workflow today. Instead, we're looking underneath at the operational foundation. So deployment, security layers, high availability, basically the things that let those workflows run reliably when you scale up. It's kind of a shortcut to understanding the platform's operational guts.
Absolutely. And these core facts, they're pulled straight from the requirements for engineers managing, advanced setups. We've distilled them into what feel like operational mandates. And what jumps out immediately is how much the platform's stability hinges less on the app itself and more on just good, solid Windows administration. We're basically building a digital fortress.
Right. And every fortress needs a solid foundation. We have to start right at the beginning with the deployment prerequisites.
Okay, so let's start at ground zero. The infrastructure team spins up a server. There's one specific Windows server role that's absolutely non-negotiable for hosting the web app. If you miss this, well, the platform just won't run. What is that critical piece?
That piece is Internet Information Services, ISIS. It often gets glossed over, seems basic, right?
Yeah.
But Orchestrator is built on Microsoft's ASP.NET Framework.
Okay.
So ISIS provides that whole web server structure. It handles the incoming HTTP requests, make sure the application can, render the UI, respond to API calls. If you skip installing ISIS, it's not just inconvenient, it fundamentally breaks how the application is supposed to function.
Right, so ISIS is step zero. Got it. Now, next big security decision. How does that orchestrator server talk to its database, the SQL database? We need that connection to be stable, fast, and crucially secure. We want to avoid that classic mistake of hard-coding passwords in config files. How do professional environments nail that secure link?
The mandated approach, really, is Windows Integrated Security. You'll also hear it called Windows Authentication. Instead of embedding, say, a SQL username and password in a config file, which then becomes this sensitive thing you have to protect and rotate all the time.
Oh, nightmare.
Exactly. You assign a dedicated Active Directory service account to the Orchestrator application pool in ISA.
Okay, but wait a second. If we're relying entirely on Active Directory for that database connection, doesn't that make that one service account a potential, huge single point of failure?
Yeah.
If someone compromises that account, couldn't they bring down the whole automation setup?
That's a fair question, and it's actually one reason security teams often prefer it. Because the connection leverages the centralized security model of Active Directory. All its activity gets logged, it's audited, it's managed by your enterprise security policies.
Oh, okay.
So you get to use your existing security tools, which reduces the headache of managing unique database credentials for every single application. At the end of the day, the security benefit of not having plain text connection strings floating around far outweighs the management risk, assuming, of course, your AD policies are solid.
That makes sense. The auditing and centralized control, that's the key operational advantage there. Okay, moving on. Final layer of foundational security. We've got the app talking securely to the database. But what about the data traveling over the network, between a user's browser or maybe another app and the orchestrator server itself? How do we make sure sensitive stuff logs, credentials, settings is locked down during transit?
Yeah, that protection layer is, it's universally required. It's SSL/TLS. Simple as that. Whether you're logging in through the web UI or robots are sending back log messages, that data absolutely has to be encrypted end-to-end. Without a valid SSL/TLS certificate properly installed and enforced, you don't just have a massive security hole. Modern browsers and a lot of corporate security policies will just flat out refuse to connect. It's the absolute standard for protecting operational data in flight. No question.
Okay, so we've built our secure server fortress. Now the challenge is letting the right people, or rather the right machines, our robots, connect securely. When a new robot machine tries to register with Orchestrator for the very first time, there's this unique credential they exchange, a kind of secret handshake. What infrastructure piece is that?
That's the machine key, sometimes called the primary key. Think of it as the unique secret ID for the machine itself. Orchestrator generates it, and the robot machine uses this key, along with Orchestrator URL, to do that initial authentication.
Okay.
It establishes that secure communication channel. Basically, it ensures only machines that the infrastructure team has actually provisioned and authorized. The ones holding the correct key can even start talking to the server.
Gotcha. Now, here's where troubleshooting can get really frustrating. We see engineers burn hours on this next point. Let's paint the picture. You've set up a brand new, unattended robot. Looks great. You've carefully entered the correct domain credentials into Orchestrator, but when you try to run a process, boom, immediate failure, insufficient permissions to log on. What critical thing did the infrastructure team likely forget on the actual Windows machine?
Yes. This is the classic operational gotcha. It really separates, the folks who've been through it before. This failure points directly to a missing Windows security permission, the logon locally permission.
But hang on, if the password was correct in Orchestrator, the account did authenticate, right? So why would Windows still deny the logon?
Because authentication proving who you are is different from authorization, what you're allowed to do. The domain account, yes, it passed the password check, authentication successful, but for an unattended robot to actually run something, it needs to start an interactive desktop session on that machine.
Wait, like sitting down at the computer?
Exactly. It needs the right to initiate that session. If the account doesn't have the logon locally, right, assigned, and that's managed through local security policy or group policy windows, will deny the session startup. Doesn't matter if the password was perfect. We've seen people check the Orchestrator credential like 20 times.
I bet.
When the real problem was just a single missing policy setting on the target machine itself.
That's a crucial distinction then. It's not about the password being right. It's about having the permission to actually use that password to start a desktop session. If you don't grant that specific right, the automation just can't create the interactive environment it needs. That's absolute gold for anyone troubleshooting those logon errors. Okay, let's switch gears a bit. Talk about resource management. Licenses, especially runtime licenses, they're critical and often pretty expensive resources. So when an infrastructure team decides to decommission an old unattended robot machine, they obviously want to get that runtime license back in the pool immediately. If they just hit delete on the robot object in Orchestrator, what's the operational snag and what's the required first step they absolutely must take?
Oh, this is a huge operational failure point. Because just deleting the object in Orchestrator, that only removes the representation of the machine from the web interface.
Right.
It does not immediately tell the licensing server to release that license. That license technically stays assigned to that now deleted machine ID, sometimes for days, making it completely unavailable for anyone else.
Yeah. So you end up paying for like ghost licenses you can't even use. How do you properly cut that tie and free it up?
The absolute required first step is to use the UiPath license management tool. You have to run that tool on the old machine to explicitly deactivate the license before you decommission the machine or delete the object. That tool does the proper handshake with the licensing server and signals that the license should be returned to the available pool right away. If you skip that, you're just blocking essential capacity.
Good point on managing capacity. Okay, let's talk configuration details. Infrastructure engineers often need a central secure spot to store environment-specific data that isn't a credential. Things like maybe application URLs, API keys, specific file paths, complex timeout values. Where does Orchestrator provide a standard place for that?
That is precisely the role of assets within Orchestrator. Assets give you that secure central governance over these kinds of shared parameters.
But why not just say use environment variables directly on the robot machines? Seems simpler, maybe. Why mandate using Orchestrator assets?
Well, you could use environment variables, sure. But doing that really sacrifices centralization and, importantly, auditability. The real value of assets is twofold: security and uniformity. First, assets can be encrypted within Orchestrator, and you can control exactly which robots or users can access which asset.
Okay, security angle.
Second, uniformity. Imagine you have, say, 30 robots running the same process, but in different data centers or regions. If a backend API URL changes, do you want to log into 30 different machines or push 30 config file updates? Or do you update one asset in Orchestrator and all robots pick it up next time they run? It turns managing scattered configurations into centralized infrastructure governance.
Yeah, that efficiency gain alone makes a strong case. Okay, finally, let's wrap up the management section with something non-negotiable before any big maintenance window or platform upgrade: disaster recovery. We need a solid backup plan, specifically a dual backup strategy. What are the two critical infrastructure components that absolutely must be backed up together at the same time?
It's the foundation and the history, essentially. You must back up the Orchestrator configuration files and the SQL database, and yet doing it simultaneously is key. This isn't just a best practice. It's really a dependency requirement for smooth recovery.
Why simultaneously, though? Why can't we just restore the database, which has all the data, and then maybe manually re-enter the settings from the config files if needed?
Because those application configuration files, they contain critical secrets, often encrypted. Things like the specific connection strings, encryption keys, identifiers. Basically, the information that lets the orchestrator application properly find and talk to that specific SQL database instance it expects.
Ah, I see.
If you restore an older database but try to use newer configuration files or vice versa, the application often just won't start up correctly. Or it'll fail critical security checks because the keys don't match what the database expects. They're intrinsically linked. Successful recovery absolutely depends on them being from the same point in time, temporally aligned.
All right, let's move into bigger operations. High availability clusters. This means multiple orchestrator server nodes sitting behind a load balancer. In that kind of setup, what critical feature does the load balancer absolutely need to use to make sure a user's web session, or maybe a robot's long-running job, doesn't keep getting bounced between different server nodes mid-task?
Right. That essential feature is session persistence. You'll often hear it called sticky sessions. Without it, the load balancer might just randomly send, request 1 to node A, the very next click or API call to node B, then maybe the third back to node A.
Chaos.
Pretty much.
Yeah.
If node A was holding some critical temporary session data for that user or that robot's connection, sending the next request over to node B means that data is just gone.
Yeah.
It leads to lost context, users getting logged out unexpectedly, failures in long communications between robot and server.
So fundamentally, you need to stick that client, be it a browser or a robot, to the specific server node that currently understands its state, at least for the duration of that activity. Otherwise, you kind of break the whole point of the HA cluster, right?
Precisely. It's all about maintaining state integrity across that clustered environment. Absolutely critical for HA.
Okay, our final core rule. This one deals with versioning, another thing that can cause really unexpected downtime if you get it wrong. What's the fundamental non-negotiable rule about compatibility between the orchestrator server version and the versions of the robots connecting to it?
The rule is crystal clear, thankfully. The orchestrator version must be equal to or newer than the robot versions it manages.
Okay, equal to or newer. But why that strict one-way relationship? I mean, if I have a brand new robot, maybe with cool new features, why can't it talk to my slightly older orchestrator server, assuming that server is stable?
Because the orchestrator server is the one that defines the rules of engagement, the API contract, if you will. That shiny new robot might be trying to use an instruction or call an API endpoint that was only introduced in the very latest orchestrator version. If the older orchestrator server simply doesn't have that endpoint or doesn't understand that new feature the robot is asking about, the communication just fails instantly. So orchestrator always has to be upgraded first. It acts as the compatibility ceiling for the whole environment. Always upgrade the server foundation before you roll out newer client endpoints like robots or studios.
And as we wrap up, let's just circle back to that dual dependency we talked about for disaster recovery, needing both the database and the configuration files together. If you were to lose both of those, you wouldn't just lose recent data. You'd essentially lose the entire operational history, the security context, the encrypted identity of your whole automation enterprise. So here's a question to think about. What systems in your own environment, maybe source control, maybe middleware, some other core platform, rely on a similarly critical dual dependency for a complete successful recovery? Do you actually know where that potential single point of coordinated backup failure might be lurking?
Definitely some food for thought there.
We'll catch you next time for the next deep dive.